Hey guys, I just went ahead and recorded myself taking the June 2017 provincial exam for Manitoba 40S pre-calculus. I actually just finished booklet 2. Booklet 1 is already up on YouTube, so I'm putting this one up. Let me know what you think. Again, it's designed to help you understand how I think about a question when I first read it, some of the steps we take, sometimes even shortcuts to be most efficient in solving the problems, and then showing also how we relate to the number of marks that each question is worth in order to maximize our efficiency on the exam. So I hope it's really helpful. Let me know in the comments below if you have any questions. Thanks.
Okay, second half of the exam, here we go. If the point 35 is a point on the graph y equals f of x, identify the corresponding point on the graph of y equals... Okay, so we're looking for transformations. X minus 1 in the brackets means to the right 1, and up 7, that's up 7. So I'm going to add 1 to my x coordinate, so 3, 5, and add 7 to my y coordinate, so this becomes 4, 12. D. 19. Identify how the graph of y equals 3 to the x and exponential is transformed to the graph y equals 3 to the negative x. Notice the negative is multiplied to the x, so that's like my k value or my reflection in the y-axis, so reflected over the y-axis, because you're going to divide all x values by negative 1. And that'll have the same impact as reflecting over the y-axis. Question 20. Exponential form, we should know this, base a, so a to the c equals b. Look for the 1, and that's answer B. Question 21, identify the graph of y equals tan x. Okay, so tan x we know, a way to remember is tan x we know is sine x over cos x. So the asymptotes are going to be wherever cos x is 0, and cos x is 0 at pi over 2, 3 pi over 2, etc. So pi over 2 and 3 pi over 2 should be the asymptote. So right now we know we're either D or C. It's definitely not A or B, because you can see that there's no asymptote at pi over 2. And then which way does it go? Well, we should know it goes up and to the right. If you need to test a point, figure out that we know when tan is in the fourth quadrant, it's negative, so that's this piece down here, as opposed to it being positive here. That's no good, so our answer is C. The volume of a box is represented by volume. Volume we know of a box is length times width times height. So 1, 2, 3 factors multiplied together, those must each represent length, width, and height. Identify a possible value for x. Well, looking at the answers, we can't have any length, width, or height be negative, so the only one that works, we can't have it be negative or 0, so the only one that works is 4 because of this bracket here, x minus 1. That can't be 0 or negative because you can't have a negative height, so it must be D. Identify a coterminal angle for theta equals negative pi over 3. Coterminal, we just add it, add or subtract 2 pi. So looking at my answers, they're all positive, so I'm going to add. So I'm going to take the negative pi over 3 and I'm going to add 2 pi. That's negative pi over 3 plus 6 pi over 3. That's the equivalent. And we get 5 pi over 3. I did something wrong there. That I didn't do anything wrong. That's not there, though. It's a good question. So you could add or subtract again. So I'm going to take 5 pi over 3 plus 2 pi again, so plus 6 pi over 3, and I get 11 pi over 3. That's the beauty of multiple choice. If your answer is not there, you got to do something else. Identify the value of n in the equation. Okay, so this is right in our formula sheet. NC3 equals NC6. We could do this 2 different ways. We could know right off the bat that n equals 9, and the reason for that is because we know the rule that, I'll write it here, NCR always has to equal NCR minus n, meaning that if you have 10 choose 7, that's always going to be the same as 10 choose 3, because choosing 7 people from a group of 10 is the same thing. When you do choose those 7, you're left over with 3 people. So that's the equivalent of just choosing 3 when you're left over with the 7. So since 3 and 6 equal 9, I know that 9C3 must equal 9C6, and that's how I jump to the answer. Identify the equation of the function for the following graph. Okay, so first things first, to look at the asymptotes. It looks like at -3, x equals -3, that's the vertical asymptote here. And then, so right off the bat, I know I need an x plus 3 on the bottom, so I can get rid of d as an option. Second thing is I've got a horizontal asymptote at y equals 2. So that means my, it's a horizontal asymptote, so that means the numerator degree over the denominator degree must be the same. We must have the same numerator degree and denominator degree. So right there we can get rid of b because there's no x on top. Both a and c have this. The question with c is that there's an x on the bottom, right? This x here. So if c were the answer, there would be another there would be a hole, at x equals 0. Which there is not. We can see there's actually even a point at x equals 0. So that leaves A as the answer. Match the following radical functions with their graphs. Okay, perfect. So you can see these are all radicals. Let's look at, you can go down the list, or you can look at your graphs first, but the first one that jumps out to me is g of x because of the -2 in front. That means it's flipped in the y-axis, so it's the only one that's going to be decreasing the whole time, so that's c. So g of x is c. Next one I would look at is probably f of x, for the reason that there's a negative inside the square root, which means it's flipped in the y-axis, so it's going to be on the left side of the y-axis compared to, we know that the regular root x looks like that. So if it's flipped in the y-axis, it's going to be b. Then the next two, one is a vertical stretch by 3, and one is a horizontal compression by a factor of 3. So we should be able to look at see what that looks like. Clearly, A is the vertical stretch, and you can see you can even plug in a point if you want. We've got the point 3, 3 here. If you plug in 3 for x in h, so h of 3 equals 3 square root of 3 minus 2, which equals 3, which makes sense that the y-coordinate is 3 here. So that's A, and that leaves this as D. 28. P of x listed as a product of factors. So we got a polynomial in standard form. We want it in factored form, so we need to look at the factors of 8. So plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Plug them in until we find one that equals 0. So I'm going to look at 1. You should be able to do it mentally. 1 will not work. -1 will also not work. I'm going to try 2. So P of 2 equals 2 cubed minus 2, 2 squared minus 4 times 2 plus 8. That gives me 8 minus 8 minus 8 plus 8, and that equals 0. Since 2 gave 0, that means x minus 2 must be a factor. To get the rest of it, I'm going to divide, use long division. X goes into x cubed, x squared times x cubed minus 2x squared minus, and we get 0. X into 0 goes 0 times. Bring the minus 4x down, and we get 0. So this will come down again. We get minus 4x plus 8. And x goes into minus 4x -4 times. And underneath that you'll get -4x plus 8. So it'll 0 out, no remainder. Therefore, this looks like x minus 2 times x squared minus 4, which can fully factor into x minus 2, x plus 2, because that's a difference of squares. So this is P of x as a product of factors. Quick 3 marks. 29. We have got a graph You can see the two zeros are at 1 and -3. Sketch the graph of 1 over. Okay, I think the easiest way to do the 1 over graphs is to keep the points where y is 1. So y is 1 there, and also put vertical asymptotes through 0. So this is going to get a little messy because I didn't zoom in enough. But it should look like that. And then for the spot in the middle, you'll also want to do 1 over a couple of, we can also keep the points at -1. So there's a point there and a point there. And then you can see the graph goes down to, what is that, -1, 2, 3, 4. So flipping that, you get -1/4. So very close to something like that. So the middle part will come in those asymptotes, go up like that and down, and the outer parts will go like that. The x-axis is going to be an asymptote too, because we can't have 0 on top since it's 1 over f of x. So it looks something like that. Then describe how to sketch the graph, the absolute value of f of x. All you would do for the absolute value of f of x, you would just take any part that's negative and flip it up. So this part would come like that, and then these would be the same. You don't have to do that because it just says describe how to sketch. So I would say make all negative y values positive by reflecting in the x-axis. Something like that. You could also say between -3, between x equals -3 and x equals 1. Something like that. So just describing that this piece here is flipping up. Describe how the value of m in this equation affects the asymptote on the graph y equals log to the base 3 of x. So we should know for log to the base 3 of x, what is the asymptote? So let's just quickly draw that. We should know our log graphs. There's always the point 1, 0. So here's 1, 1, 0, and then 3, 1. 3 and 1, and our asymptote is at 0, right? Is at x equals 0, the y-axis. If we are minusing by m, that is going to affect the asymptote, right? Because that's just a horizontal shift, so it will be shifted m to the right in this case. And if it was negative m, then saying it shifted negative to the right, that's to the left. So describe, I would just say the vertical asymptote will shift m units right. And the equation of the asymptote will be x equals m. That might be a nice thing to add in. That will be the equation of the asymptote. Because we're starting at 0 and it's going to shift m away, so it'll just be m. Solve algebraically. It's two ways of solving algebraically when they're exponential functions. We can make the bases the same, or we use our calculator. This is not a calculator section, and we can see that 25 and 1/5, you can make those the same. So I'm going to go ahead and do that by using base 5. So 25 is like 5 base 2x equals 5 to the -1 of -3x plus 1. So this is 5 to the 2x equals 5 to the 3x minus 1. I'm just multiplying. Once the bases are the same, we can drop the exponents and set them equal. So 2x equals 3x minus 1, and we get 1 equals x. Cos 2 theta equals 0. This is worth 4 marks. Solve where theta is an element of the reals. So notice the domain they give you. That's going to be a general solution we'll want, because it can continue on forever. Cos 2 theta equals 0. Well, I would do that. You might be tempted to change to one of the identities, like use the formula, but I would just say let's make cos of x equals 0. So as a note, x equals 2 theta. And where does cos x equals 0? Well, x, that will happen at pi by 2. It doesn't say whether we're in radians or not, but pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, etc. However, we know x is actually equal to 2 theta, and we're solving for theta. So the real answers for theta is you would divide all these by 2. So it's pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4, etc. And you can see the pattern. It's every pi from pi by 4 on, or every 2 pi by 4. The next one you can see would be 9 pi by 2, and you get to 9 pi by 4. So it's increasing by, so it's theta. The general solution is you can start at pi by 4, and you can add 2 pi by 4, k, where k is an element of the integers. Some people use I for integers, or z. I'll write both of those there because it could be either. And if you reduce the 2 pi by 4, it's pi by 4 plus pi by 2k, where k is an element of the integers. So that's the way I would do this one, is set up, replace 2 theta with x, solve for x, and then restate that that's actually equal to 2 theta, so you have to divide them all by 2. 33, describe a difference between these graphs, f of x, and so the only difference it looks like is the negative in front here. So f of x, it's one mark, so f of x is g of x reflected in the x-axis. We could also see that the degree is 3 for both of these. So you could comment on the end behavior. F of x, because it's negative, it's going to go from quadrant 2 to quadrant 4. Versus g of x, because it's positive and a cubic, that's going to go from quadrant 3 to quadrant 1. Both valid comments, I think. Given the graph of y equals f of x, sketch the square root. So when we have to sketch the square root of f of x, it's just the square root of the y values. So we only have to concentrate on the positive y values because you can't take the square root of a negative. So first thing is square root of 0 is still 0. So I'm just going to keep my points at the zeros there and there. Oh, I guess I can draw it down here. So there and there. And the square root of 1 is also 1. So I'm going to keep any point where it's 1 and 1. Again, the y values is all you're focusing on. And then I'll take the peak point as well. That looks like it's at negative 2, 4. So it now becomes negative 2, 2 because the square root of 4 is 2. Remember, the x values stay the same. The y values change. So my graph is going to look like this. Make sure you show, sorry, it's sort of sloppy here, but make sure you show that the curve goes outside the line at the beginning and then tucks inside the line. And that's because the square root of a fraction is actually higher than that fraction. Describe the relationship between the zeros of the function, the roots of the equation, and the x-intercepts of the graph. Okay, so it's the exact same equation, and this is the exact same thing. So the zeros of f of x are 1/2 and negative 3. Those are just the values that make the two brackets 0, which is the same, which are the roots of 2x minus 1, x plus 3 squared equals 0, and also are the x-intercepts of y equals f of x. So it's just getting you to notice the different ways of stating quadratics. The whole point here is that the relationship is they're the exact same thing, just different ways of saying it. 36, we've got a trig function to graph. Sketch a graph of at least one period of the function f of x equals Okay, so this is definitely tricky because it's got the horizontal stretch. A couple ways of doing this. I would start with probably the original cos function we could do. It might even be easier to do a couple different things. So period equals 2 pi over b, and b or k, whatever you want to say, is 1/2. So the period is going to be 4 pi. So right there I would try and go from 0 to 4 pi maybe, although we're shifted pi by 2 to the left. So we're shifted pi by 2 to the left. Instead of going 0 to 4 pi, we're now going negative pi by 2 to 7 pi by 2. So that will be one full period, which is kind of nice. And it's shifted down -3. Okay, so what I would maybe say is the original, if we're saying this is 1 and this is -1, I'll need to go down to -4 here. -2, -3. Normally, if this were if we didn't have the vertical shift, we know that that cos starts at the top. So I've already shifted to the left pi over 2. So I would start there. It would come down, hit at -1 in the middle, and end back up here. Right, so that would be the normal one. I'm just going to shift it down 3. So the actual function 1 goes down to -2, and 1 goes down to -2, and my -1 drops to -4. So it's going to look something like this. Now, if they want it, that's not the greatest drawing, I apologize. But if they wanted something more specific, like where's this midpoint where it hits the minimum, we know it's just right between 7 pi over 2 and negative pi over 2. So you can just take the average of the two. So we get 6 pi over 2 divided by 2, so that's 3 pi over 2. So that could be helpful, and that should be enough to show them. So again, just to reiterate what I did there, I took the period using my 2 pi over k value, found the period was 4 pi, and I only was supposed to graph at least one period. So I knew normally it would go from 0 to 4 pi, but it's shifted to the left pi over 2. So I shifted the 0 to negative pi over 2, and I shifted 4 pi, which would have been here, which is the same as 8 pi over 2, left pi over 2 to 7 pi over 2. Verify that theta equals 4 pi over 3 is a solution. A couple ways of doing this. You could just plug it in and show that it's a solution. So maybe I'll do that since 4 pi over 3 is a value that we know. So 4 cos squared of 4 pi over 3 and minus 1. And so just solve the left side. Note that cos squared is the same as saying cos 4 pi over 3 all squared minus 1. Cos of 4 pi over 3 we can think is negative 1/2. So 4 times negative 1/2 squared minus 1. And that equals 4 times 1/4 minus 1 equals 1 minus 1 equals 0. So equals the left-hand side. I think that's the easiest way, or equals the right-hand side, sorry. That's probably the easiest way, just plug it in. Describe how to determine the equation of the horizontal asymptote of a rational function when the degree of the polynomial in the numerator and the degree of the polynomial in the denominator are equal. So we saw this in an earlier question. When that's the case, take the coefficient of the degree term divided by degree term in numerator divided by the coefficient of the degree term in the denominator. For example, if it was 2x minus 1 over 3x minus 1, the degree is 1 and 1, so we just take 2 over 3, and it'll be y equals 2 over 3. But that should be good enough. That will be the equation. Yeah, we could even add, I guess, y equals the quotient of those two. That will be the equation of that horizontal asymptote. Evaluate cotangent. That's 1 over tan. So I'll say this is 1 over tan negative 5 pi over 6 over sine of 17 pi by 3. 17 pi by 3, we probably want to figure out what that is. So I'm going to minus 6 pi by 3 because that's 2 pi. To get 11 pi by 3, we're still not in the circle, minus another 6 pi by 3, and that's 5 pi by 3. So this is the same thing. These are just coterminal angles of 5 pi by 3. So tan of negative 5 pi by 6, that's going backwards. So if we had a negative 5 pi by 6, that's going to be right here. And we can see that that's positive 1/2 over root 3 over 2. So 1 over root 3 is a root 3 over 3. And so it's 1 over root 3 over 3. And sine 5 pi over 3 is going to be right here, which is negative root 3 over 2. So if we simplify this, we get 1 over a fraction is just, you can just flip that, so it's 3 over root 3 all over negative root 3 over 2, which we can, kind of running out of room here. I'll write it, yeah. Instead of divide by the fraction, we can flip that fraction and multiply it, so 2 over root 3 negative. And root 3 times root 3 is 3, so that cancels with the 3, and we're just left with negative 2. A little bit complicated there, but that should work. So when you divide fractions, you flip the bottom fraction and multiply. Root 3 times root 3 is 3, which cancels with the 3 on top. We're getting through it. Sketch the graph of the function f of x equals negative 1 over x minus 1 squared and determine the range. Okay, lots going on here. First things first, I would set a vertical asymptote at x equals 1 because that's what makes the denominator 0. Then I would probably go 1 point out each way. So when x is 2, y you can see is going to be negative 1. So I'll draw that here. So that's negative 1. And when x is 0, y is also going to be negative 1. Great. And you can see that the bottom is always going to be positive because it's squared, and the top's always going to be negative, so everything's going to be below the x-axis, so we know it's going to look like this because don't forget to make the x-axis an asymptote because it can never be 0. So it's going to look like that. Draw your asymptotes, add in some points using just table of values, and make sure you add in your horizontal asymptote. So the range of this is y is less than or equal, sorry, not less than or equal, y is less than 0. Or if you wanted an interval notation, you could write negative infinity to 0 with a round bracket around it. So it's going all the way down but never hitting the x-axis. 41. Determine g of f of x. Okay, so we need to put the whole f of x function in for x in the g function. So this is the same as saying g of root x minus 2, which equals root x minus 2 squared plus 1, because I'm putting this right in here. When we square a square root, we get x minus, we just cancel them, plus 1, which equals x minus 1. So you can write that right there, x minus 1. Explain why the domain of g of f of x is restricted. Okay, so that's a good question. It looks like it's x minus 1, so it shouldn't really be restricted. However, we know that we're actually using f of x inside, right? So the domain of g of f of x is actually restricted by whatever the domain of, whatever the range of f of x is. So let's think about f of x. It equals the square root of x minus 2. So we know that x has got to be greater than or equal to 2 because we can't take the square root of a negative. And so f of x is always going to be positive. F of x is always going to be positive, greater than or equal to 0, I should say. So we can say, really we can just say that the domain is going to be the same as the most restrictive domain within. So it's just x is greater than or equal to 2, because really what's happening when we look at this x minus 1, it looks like it's fine and normal, but what happened was that the squared negated the square root, when really we've actually got to solve for that first. 42, solve algebraically. 2 log base a of 3 plus solve algebraically. First thing I notice is that the bases are the same, so I'm going to put them together. Log base a of 3 squared, because the coefficient can come on top, plus log base a of 4 equals 2. This is 9, so we get log base a of 9 times 4, which is 36, equals 2. A to the 2 equals 36. Once we're down to one logarithm, you change the form, and a must equal plus or minus 6, but then you go back to the question and say, oh, a is greater than 0, so a must be plus 6. 43, secant theta plus 2 equals 0. Solve over the interval, so I want where secant theta equals negative 2. It's just a simple trig function. This is where 1 over cos theta equals negative 2, so cos theta equals negative 1/2, and that happens on the interval of just one circle. Negative 1/2 happens at 4 pi over 3 and 5 pi over 3. No, that's a lie. 4 pi over 3 and 2 pi over 3, excuse me. And just to be nice to them, we'll write them in order. 4 pi over 3 and 2 pi over 3. If you don't know your unit circle too well, notice that it equals 1/2 at pi over 3 in the first quadrant. And then to get to the second, we know cos is negative in quadrant 2 and quadrant 3. And to get here, we do pi minus pi over 3 and pi plus pi over 3. Determine the x-intercept of the graph. X-intercept is where y is 0, so e to the x minus 1. So 1 equals e to the x. You could ln both sides, or notice that something to the x equals 1 only when the exponent is 0. So, but you can also ln both sides. Ln 1 equals x ln e. Ln e is 1. Ln 1 is 0, so 0 equals x. Given the fifth row of Pascal's triangle, determine the values of the next row. You just add values. So 1 and 0 is 1, 1 and 4 is 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5, and 1 and 0 is 1. That's the next row. Log 2 of 80 minus log 2 of 10 equals log 2 of 80 over 10. Two logs with the same base, we can divide the terms inside if they're subtracted. Log 2 of 8, and that equals 3, because 2 needs to be raised to 3. State the amplitude. Amplitude normally of a sine function is 1. It's from the midpoint to the top, and this is stretching it by a factor of 2. The reflection doesn't matter, so the amplitude is 2. Not negative 2. Determine the exact value of cos 15. That's one of those key values we should see that we don't know what it is. There's no calculator, so we must use two angles that we do know. 15 degrees can be found from 45 degrees minus 30 degrees, two values we do know. So I'm going to use cos of a minus b, equals cos a cos b plus sine a sine b. And so we want cos of 15, so this is cos of 45 minus 30, which equals cos 45 cos 30 plus sine 45 sine 30 degrees, 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 degrees. Cos 45 is root 2 over 2. Root 2 over 2. Cos 30 is root 3 over 2. Plus sine 45 is root 2 over 2. And sine 30 is 1/2. Yes, it is. Equals root 6 over 4. You just multiply tops, multiply bottoms, plus root 2 over 4. You can combine these and you get root 6 plus root 2 over 4, and that equals cos of 15 degrees. Dead giveaway whenever it's 15 degrees or 105 degrees or something like that. Or, you know, pi over 12 is a good one with radians to look out for. 49. Two functions determine h of x when we subtract the functions. So subtracting x squared plus 5x plus 6 minus x plus 3. X squared plus 5x plus 6, we should notice right away that that can factor into x plus 3, x plus 2, minus x plus 3. So we can see there's a common factor here of an x plus 3. Take that out and you've got x plus 2 minus 1. So this is just x plus 3, x plus 1. That'll be a really nice way to leave it so that we can graph it, because now it's just a nice little quadratic with zeros at -3 and -1, and at -2 I'm going to put h of -2 to find the vertex. I would get -1, I'm sorry. So it's down here, and so it looks like that. Nice and easy. So look for things like the factoring. Hopefully that quadratic jumped out at you that it can be factored. And question 22, because I forgot to put it in order, identify which of the following graphs represents a logarithmic function. Okay, that's a good question. So we definitely need a vertical asymptote because we know we can't take the log of a negative. So right there we've got this one and this one. This is no good. That looks like a root function. This looks like an exponential function. And we know, again, it's not going to be this value because we can't take both sides of it, right? There's only going to be a spot where you can take the this is clearly a reciprocal function, right? Where there's a horizontal asymptote as well. So the horizontal asymptote combined with the vertical asymptote means it's some sort of rational. So it's clearly example B. Hopefully that was helpful.